cool. How many of you have used LangChain? Oh, wow, quite a bit. Okay, so this talk may be introductory to you. For the rest of you, this is going to be a gentle introduction to LangChain. So hopefully you're excited because I am very excited. I like LangChain a lot. Okay, so you can find my slides with this link if you want to. Let's get started. Before I talk about LangChain, I want to talk a little bit about myself. My name is Sophia Young. My background is in psychology, statistics, and computer science. I've been working at Anaconda for 5 years. I'm a big fan of open source Python community. So I contributed and created some Python open source packages. I also volunteer at various Python open source community. I also have a data science and machine learning book club. We read one book a month and we chat with the book authors at the end of the month. So this month we're reading PyTorch. Next month we're reading generative AI. If you're interested, join my book club. And we have more than 1,000 people in the book club actually. So it's a fun community. So agenda today, we're going to talk about what is LangChain, how do we use LangChain. I'm going to cover some of the basic topics of LangChain, such as chains, tools, agents, what are those, how to use those. And then finally, I'm going to do a demo of a chatbot using LangChain and panel. Okay, so what is LangChain? LangChain is the framework for developed applications powered by large language models. So when you develop an application, you not only want your large language model, your application to interact with your large language model, you also probably want your application to be data aware. Want to connect your large language model to other sources of data, whether you have a document in PDF format or text format or a CSV file or whatever data format you have. And also, we also want our application to be agentic, which means we want to allow our language model to interact with this environment. For example, if the environment has different set of tools, we want our language model to be able to understand and use those set of tools. So this is a basic graph of what we are familiar with when we use ChatGPT or Bard. It basically works this way. Well, we as a user give our language model an instruction, and this instruction get fed into a prompt, which then our language model get the prompt and be able to generate text and generate some output based on the prompt. So that's basically how normal ChatGPT and other language models work. So what can LangChain contribute to this process, right? There are several things. First of all, with LangChain, it not only works with one language model, it works with many different model providers, such as OpenAI, Huggingface, or even your local models like Llama, Alpaca, and others. Right? It provides a wrapper to wrap around all the language model provider APIs. So you don't need to learn different APIs anymore. You just learn LangChain and it works with all the different model providers, which is really nice. And the second thing that's important is memories. When you work with ChatGPT API, right? When you call the ChatGPT API, it doesn't keep your chat history. It actually doesn't know the context to which you have communicated with the language model. So with LangChain, you might want to keep that different types of API, whether it is your chat or maybe summarizing your previous chat with the language model. So it's memory aware for our language model. So it's really nice to have this memory functionalities built in. There are actually, I think, 6 or more types of memories that LangChain provides. We're gonna talk about that in a little bit. And then when we talk about chains, what does that mean, right? When you work with different language models, you might want to chain different language models together. So your output of one language model could be the input of another language model, Or if you have 3 language models, your output of your first 2 language models could be the input of your 3rd language model. And then together, they work together to produce some sort of output. So that's chains. And then furthermore, tools are a very important concept, right? It's like ChatGPT plugins. So all the plugins are tools. You can use Google search, you can use a calculator, Python wrapper to execute Python code using various tools APIs. So LangChain makes it super easy to provide you access and interface to interact with those tools. And then how does the language model determine which tools to use? So that's where the agent comes from. The agent is basically a language model that give the prompt of all the description of the tools and have some sort of framework to decide, okay, which tools I want to use for this specific task. So that's agent. That's one of the core concepts in LangChain. And then finally, if we have outside documents, different data sources, whether it's PDF, right, CSV, and how do we feed that document into the prompt? You might think, okay, I just take all the text from my document into the prompt. Right now, I think last week, Anthropic just released the 100K token. So with that much token, you can potentially feed into our language model the prompt with hundreds and hundreds of pages of documents, right? But for other models, you probably only have thousands of token limits, right? So you would need to find a way to kind of extract what is meaningful from the document based on your prompt. So LangChain provides different document loaders to load different types of documents, providing you vector databases to store your information from the document, and also providing different retrieval mechanism to retrieve what is the relevant information you want to get from this document, and feed only the important information into the prompt and into the language model. So this is the basic of LangChain. It has much more features than this, but this is like the basics of LangChain that I understand. Any questions so far? Or any comments? I know some of you are probably super users. If you have other opinions about LangChain, please let me know.
Can I ask about the document loader? So there's Llama index. So is that how it loads a document? Doesn't Llama index do that kind of document, or is it just LangChain?
That's a great question. So Llama index provides more flexibilities into if you want to interact with different source of metadata with different queries of the data. I think Llama index is a more powered version of LangChain in the respect of retrieval, document loader, that kind of thing. It only does this one thing really good. But LangChain is a whole ecosystem with a lot more functionalities. Some people use LangChain with Llama index together to make them work. But a lot of times, if you just want to use LangChain, it's all possible as well. Like I'm going to show you, everything is going to be in LangChain. Yeah, that's a great question.
Oh, thank you. Thank you for answering.
Yeah, if you have other opinions about Llama index, I'm curious to hear about it.
No, I just had heard that was kind of a specialized thing. So I was wondering if most people use Llama index as a plugin to LangChain. Or
yeah.
Okay, that sounds good.
Yeah, it has other functionalities in the document parts, but like LangChain is other things. So it has different specialties to tools. I think if you like, you can use them both. Okay, now we're going to talk about how to use LangChain. I have 2 notebooks here that I'm going to go through today. If you're interested, you can click the link here. We'll link to the notebooks. So let's first of all talk about how do we work with different large language models with LangChain. So as I mentioned, LangChain provides standard interface to interact with a variety of large language models. Here's a list of model providers, which is pretty impressive. The ones I use a lot is OpenAI APIs, Huggingface Hub, to load any of the Huggingface models, I also use Cohere, provide pretty good models as well. And then we have Llama CPP. Yeah, so if you want to load your local Llama model or alpaca, it actually provides a lot more than Llama models. It's a list of Llama-based models that you can use with Llama CPP. And yeah, so here's the code. I hope you can see. Basically import different modules from LangChain and use similar APIs to load all of our data, all of our models. So here we have a ChatGPT model where we use the OpenAI API and we give it a model name. The ChatGPT model is GPT 3.5 Turbo. And then if you want to load a GPT-3 model, it's the OpenAI API model name is this one, and then Cohere model and then Huggingface pipeline. This actually download this Bloom model to your local machine and you run things locally here. So one thing to note is that there is this OpenAI and OpenAI API is kind of different. With ChatGPT, it's kind of providing different types of interface. If you use OpenAI API, you will notice that as well. You will provide them not only the human message and also system message, and also like when it returns something, you will give you an AI message. So basically you can define different types of messages for ChatGPT APIs. Here's what it looks like for ChatGPT. Again, we said we give it a human message, how to be happy, and it returns an AI message with 6-7 different things. Yeah, it's pretty good, I think. And then with GPT-3, you can see 10 different things, all pretty reasonable. We have Cohere models, provide different types of information, also makes sense. And then Bloom model is not very great because it's just keep telling us, I was happy to see the sun shining through the cloud, and just keep repeating the same sentence over and over. So yeah, so that's Bloom. Yeah, it just till the end. We define a maximum token. That's why I just like cut off here. So yeah, Bloom is not great in this case. Anyways, so next I want to talk about memory that I mentioned. There are 1, 2, 3, 4, 5, 6, 7, 8 different memory types. You can have conversation buffer memory, which means you keep all the memory histories. Conversation for window memory keeps, like, you can define how many past interactions you want to keep. You can summarize your memory. If you have a lot of memories you want to keep, you might want to use a vector store backed memory, where you store all your memories in the vector database and then retrieve your relevant memories when needed. So I want to show you an example of how it works. So in this example, I actually use 2 different memories and combine them together. So first of all, we have the conversation buffer window memory, where we define k = 1, which means I want to keep the last 1 interaction in my chat history. And then the second memory I'm using is the conversation summary memory, where I want to summarize the conversation over time. You can see the summary memory need a LLM to summarize. So it's like an additional call to summarize your memory every time. And then you can combine those 2 different memories, like in this memory parameter, and give it a list of all the memories you want to use. And finally, you can draft a template. This is the default template it's using. So basically, it's telling us the AI, if the AI does not know the answer to the question, it says it does not know. So this is kind of important to make sure the AI doesn't hallucinate too much, although it will still hallucinate. Yeah, so you can see like different places. You can see where we insert the history, the summary of the conversation here, the current conversation, which is the past 1 interaction of the conversation here, and then your human input is the question you ask every time. And then with the prompt template, you can chain basically your large language model with the memory module and with a prompt together in a conversation chain. So that will give you everything you want to go. Okay, so here's an example where I said hi. You can see the summary of conversation and the current conversation is empty because there's no previous conversation yet. I said hi. AI said, hi there, how can I help you? And now I asked, can you tell me a joke? Right, so now the summary of the conversation becomes the human grades the AI, to which the AI responds and offer to help. The current conversation is what we have, like, hi there, how can I help you? And can you tell me a joke? And now the AI said, sure, what did the fish say when it hits the wall? Human said, I don't know. AI said, damn. So yeah, it's a terrible joke. Yeah, and now let's try another one. Can you tell me a similar joke? Now the summary of the conversation becomes the human asks the AI to tell a joke, to which the AI responds with a pun about a fish hitting a wall. The current conversation, you can see I don't have the hi there anymore. We only have the last one round of conversation, and then the AI gives us another joke. It's basically the same. I guess the only difference is slamming to the concrete wall. AI said, damn it.
The emphasis on the similar.
Right. You understood, right? Yeah. So it's quite fun. Yeah, next up, I want to talk about chains. Like I mentioned, with the chains, you can chain different large language models together. I want to go through this example with you. So in this example, basically, where the first large language model, we're asking what is a good name for a company that makes certain product. And the output of the first task is to give us a company name. And the second chain is write a catchphrase for the following company. The company name is the company name that generated from the first language model, right? So basically we're chaining two language models together in one go. So here is basically more detailed syntax. So we have a LLM chain for each of the individual chain. The LLM chain basically chains the prompt template with a large language model. You can see it's a LLM, which is I'm using ChatGPT AI here, and the prompt is using a prompt template. And then similarly, the second chain, again, is a LLM chain with language model and also prompt template. And then finally, I use a simple sequential chain to chain those two large language models together. You can see chains equals chain and chain two, right? So there are different types of chains. You can chain different things together. You can also customize how you want to connect your different models together. So simple sequential chains, basically taking the output of the first chain and feeding to the second chain as the input. And now when you run this thing, it first generates the company that makes, okay, yeah, because we ask it to generate a company name for that makes colorful socks. The name it generated is Rainbow Socks Inc. And then the catchphrase is put a little color into a step with the rainbow socks, which is pretty good. So that's chains. Pretty nice. And next up, I want to talk about tools. I know it's a lot of information. It's quite fun. LangChain has a lot of functionalities. That's why it's really exciting. So yeah, the reason why ChatGPT plugin is so popular and so nice is because it can interact with the outside world with other tools. With LangChain, you can interact with outside tools using Python code as well. So it providing a bridge between your large language model and your Python wrapper to execute your Python code, your calculator, your Google search, and so on. It provides a list of different tools for you to use. So it basically wraps around different. So each tool is basically an API. Here is a Google search API. LangChain provides a wrapper around that tool. If you see the code is basically just one Python file, super short, it's not even that long. It provides a wrapper for different tools for you to use. So the question is, how does it work, right? LangChain is using agent to be able to interact with different tools. So again, here's another example where we're trying to use two different tools. We're using the Google Search API and also a calculator, basically. And to initialize the agent, we tell them, okay, I want to use those two different tools, and I give it a large language model to understand and interact with those tools. And this agent is a zero-shot React description agent, which is a default agent LangChain provides. LangChain actually provides 4 different agents. This is the default, which is a React framework. That's why React is there. I'll explain what is React framework in the next slide. But here is an example. I use the agent to run what is Leo DiCaprio's girlfriend, what is her current age raised to the 0.43 power. Right, so our large language model was able to understand, okay, I need to find out who the girlfriend is and then find her age and calculate it raised to the some power. And the first action is to do a Google search, and the search input to the Google API is Leo DiCaprio's girlfriend. And then he was able to get some answers and find this girl, right? And the search for this girl's age, it was 25 years old, and now the thought is I need to use a calculator to calculate what is 25 raised to the 0.43 power. And now it was able to use a calculator calculating the final answer and get the final answer. So this is quite interesting, right? So this is how it works. I hope you can see. So this is actually the prompt that feed into large language model to do this whole thing. So it was answer the following questions as best as you can. You have access to the following tools. It gives you the description of the tools. That's how the large language model is able to choose, okay, which tools I want to use, because we give them the description, right? Search is a search engine. Calculator is useful when you answer questions about math. Although I don't know if that's a good description for a calculator, but that worked. So using the following format, question is the input question you must answer. Thought, you should always think about what to do. Action is the action you need to take. Should be one of the following the tools you provided, right? The action input is the input to the action. Observation is the result to the action. And this process can be repeated many, many times. And then it gives thoughts and final answer. So the React framework is basically telling you React, I think it stands for reaction and thoughts, reflections, something like that. So you not only take actions on the prompt, you also think about what you need to do. It's like what we humans do, right? We get a task. We not only just do it, we think about how to do it first and reflect on whether we have done it wrong or what to do the next step. So that's the React framework to ask the language model to actually think about it and then do some certain actions. Here's another example. I'm going to show you that we have a Google Search API and I have Python REPL here doing pretty much the same thing. And you can see it's similarly using a Google Search API first and then use the Python REPL. Yeah. You can see it's using current age to the power of 49. I was using a different number here. You can see it was able to generate the Python code and execute the Python code using the Python tool here in the agent. Yeah, so that's agent. I think we still have time. Yeah. Okay, so next up, the final section, I want to talk about documents, right? We want to interact with our documents, our outside external data sources. How do we do that? So there were 3 key things that LangChain make document interaction super easy. The first thing is document loader, which there are 3 types of document loaders. Transform loader, which transform data from a specific format into the document format. So the document format is like, if you use pandas, you have the pandas data frame, right? For if you use LangChain, you have the LangChain document format. That's how LangChain was able to talk to the document. It's basically a document class with some specific functions. Yeah, Yeah, it can also load different public data set. I think it has some built-in tools already, or document loaders you can use already, like Hacker News. If you want to load Hacker News, it's super easy. You can also load data from specific format of applications or cloud services. Like if your data is in AWS, GCP, right? You can use document loaders to load those data. And the second thing that's important is vector databases, because we need to embed those text from the document, feed into the vector databases, and to be able to retrieve later. There are different types of vector databases. There's a whole list on the LangChain webpage. If you're interested, you can see the differences. And then retrieval, when you ask a question, you want to see which part of the document is relevant for my question, and I just want to get that relevant information. Okay, so here's basically how it works. There are different ways to interact with a document. All those code can be simplified with one line of code, but I just want to show you exactly how it works. So I have them in different lines for each step. So first of all, we load the document. Here I have an example.pdf file. I use the PDF document loader to load the document. And then I split the document into chunks. And then I use a OpenAI embedding API to embed my text into vectors. And then I create a vector store using Chroma. Chroma is, I think, is probably the default vector store that LangChain uses. It actually create a local local.chroma file, and then you can use that for retrieval. So in the retrieval step, there are different search types, right? You can search for how similar is this vector to my question vector, right? And I want to just retrieve the top two, the most similar text that's to my question vector. And then you can create a retrieval QA chain, which there are different chain types. There are different nuances here. MapReduce is if your document is super big, you might want to only feed into part of your document. That's why we have text chunks here. And then you answer questions for each part and then summarize them later, right? There's also stuff chain. If you feed your whole document through the stuff chain, and if your document is over the token limit, it will actually give you an error message saying it's too big. So be careful with MapReduce chain though, because if your document is super long, it will take a lot of tokens, and because it's scanning through all the documents, feed all the documents into your OpenAI API, and it can be expensive. And then you can see running and get. You can ask the question, I think the question, how many AI publications in 2021? And it will show you the result from this document. So if you want to have this retrieval QA chain return, what is the source document? It was looking to get the answer. You can add this return source document equals true. And then here's the result where we have the query, the result, and the source document is two of the most relevant document that's similar to our question here. Okay, so I'm not sure why this is not. Okay, anyways, so I think we have 5 minutes for questions in my last demo. I'm gonna show you how I built this chatbot using LangChain and panel, where I basically have this chatbot to interact with my PDF file and ask questions, and it was able to give me an answer. Okay, so the code is here in this notebook. Let me here. Okay. Cool. How many of you have used Panel? Yay! Thank you. Panel is great. It's one of the popular dashboarding tool. I recommend you to give it a try because it's amazing. yeah, let's refresh it. You can have a preview of the model. And okay, I don't want to show you my API keys though. Is it? Let's see. Okay. Sorry, I'm just gonna go through the code with you. So here you can see with panel, is we import panel as PN to load our panel modules. And you can see there are different components in this dashboard. We have different widgets. So each of those sections is a widget. For example, this file input widget, can you see, is it big enough? This file input widget defines this one, where you can load a file. And then we have the OpenAI API key widget here. If you type anything, right, it's showing as a password is hidden because we asked it to be a password input widget. And then later we have a prompt, which is a prompt widget. And then run button is a button widget. And then each of those is a widget as well. You can define different widget with panel super easily. And this part should be familiar to you. We just went through this, where we have a file, we give it a query, and it will return the result. I also have the chain type as a parameter, and a K is number of relevant documents as the parameter here. So you can see we can choose different chain types, and we can choose number of relevant chunks that you want to retrieve. And then to be able to display everything here, we need the result not to be a text string, but it need to be a panel object, right? So that's why in this function, it's basically turning the result into, you can see here's the result. I'm turning this result into a panel object. This is kind of complicated, but it's just layout, right? I want to lay out everything. This is an emoji. Yeah, this is an emoji, and I want to, after the emoji, I want to show the result. And column is we lay out everything in a column, and then it returns a panel object that can show up here. So the next thing, the magic of panel is that you want to bind this function with a panel widget. So whenever we click this run button, we want to run this function. And only when we click this run button, we want to run this function. So this PN bind is binding this widget with the function. So whenever you click the button, it's interactive, right? So that's basically that. And we have different layouts, and that's it. And you can see the, if you want to preview your